Hey there, class. Mr. Prusky here. Hope you're having a good day so far. We're continuing with Chapter 11. This is 11.5. It's about multiplying and dividing rational expressions. Basically, this is going to be basically like taking care of multiplying and dividing fractions, but with more complicated expressions, okay? So, let's talk about some rules to remember here. We can cancel diagonally. Yeah, but we cannot cancel horizontally, okay? We can cancel diagonally, but not horizontally. Also vertically, but just so we're kind of clear there, okay? All right, so let's go ahead and I guess if you want to try number one's kind of a review from Chapter 8, okay? What I would encourage you to do, why don't you see if you can figure this one out in your head if you'd like to pause it, but what I would first do is multiply straight across and then do some reducing and canceling. See if you can do number 1, which is kind of a review from Chapter 8. All right, so let's multiply straight across here. So what numbers can we multiply? Well, we got 6 times 10, which is going to be 60. We have x to the third. There's no other x's on top. And how many y's are we going to have? Y to the what? Is it going to be 12 or 7? When we multiply, we're going to add the exponents. It's going to be 3 plus 4, which is 7. On the bottom, 2 times 18 is going to be 36. We have 2 x's down here, and we have y squared times y squared is going to be y to the 2 plus 2 is 4. All right, if you'd like to pause again and see if you can reduce this, give it a try. All right, now we want to find the biggest number that goes into both of these, which is going to be, let's see here, 6, I think it's 12. Yeah, it should be 12. 12 goes into 60 how many times? 5. 12 goes into 36 how many times? 3. How many x's are going to cancel? Well, we have x squared. It's going to cancel, and then we have, if we take away 2 x's, we take away 2 from 3, we're going to have x to the first. How many y's are going to cancel? Cancel 4 y's, we have how many left? 3 on top, 7 minus 4 is 3. So our final answer is going to be 5x y to the third, all over what, 3? Okay, and I forgot to mention the fraction wrap, but when we multiply fractions, you multiply straight across, okay? Straight across the top, straight across the bottom, and then you simplify, okay? All right, number 2. Similar problem, we just have like a little bit more complex things with some rational expressions. So let's do the same thing here, okay? So let's multiply what we can multiply together here. So we have 4 and 14 we can multiply, right? I would not distribute this. I'd kind of keep the m plus 3 to the second the same. So what's 4 times 14? That's going to be 56. I'm going to put n in front. There's only one n over here on the right. And then I'm just going to put m plus 3 squared. With simplifying expressions and stuff, I would not distribute. We want to keep it in like kind of I guess simplified as possible. Like we don't want to like multiple. We don't want to like distribute this and stuff, right? And all that. Okay, we want to kind of keep it separate. Okay. On the bottom, we have 7 times 6, which is going to be 42. N squared times we have n plus 3. All right, now we can. Why don't you see if you can factor and see if you do any canceling here? Give it a try. All right, what number goes into 42 and 56? That's a little tough. What is that? Give me 1 second here. I'm figuring this out in real time. Looks like 14. Oh, yeah, 14 goes into both of these. So, all right. So, 56 divided by 14 is 4. And 42 divided by 14 is going to be 3. How many n's are going to cancel? Well, we have 1 on top, 2 on the bottom. We're going to cancel the smaller one, which is into the first. Take away 1 from the bottom. We have this. How many m plus 3's are going to cancel? Well, we have 1 down here, we have 2 up here, so I'm just going to cross that out, and now I have m to the third, the first power up here. So what's our final answer going to be? On top, we have 4 times the quantity, parentheses, m plus 3, all over, and then we have 3n on the bottom. That's our answer. All right, okay, it's a little bit more complicated version of multiplying fractions. Okay, we're going to do another one here, which is going to be a little bit challenging. Let's see, let's look ahead here. Okay, so here's what I want you to do here. If you want to try these on your own, you can. I want to change number 3. Change this 5 minus y on the top right to y squared to y minus 5 squared like this, okay? And over here, I want to change number 4, the top left, to 27x to the third minus 3x. Yeah, it should be minus 3x. I believe that should work. I'm kind of making this up here as I go. It should be fine. If you guys want to pause these and give them a try, go ahead. Otherwise, we're going to go through them in a second. All right, number 3. So we're multiplying across again. Multiplying fractions, no big problem. Top times top or bottom times bottom. So what do we have on top here? Well, we have 8 times 25. If you want to, you could also reduce first. Like you can reduce vertically or diagonally, but let's just do this. So you could, if you want to, you can reduce the 8 and 4, right? You could change this to a 2 and the 4 to a 1 if you wanted to. Or you can multiply straight across. So let's do 8 times 25 is 200. I'm just going to do it the way that I taught you because I think it'll be a little bit cleaner, and we'll see what happens here. Okay? And then we have y minus 5 squared over, what's 15 times 4? On the bottom, 15 times 4 is 60. Times, then we have, how many x plus, I like to put the stuff over the top here. So we have x plus 2 to the third times y minus 5. All right, now we combine everything here. Now we got to reduce stuff. What number goes into 260 nicely? Yeah, I think it's going to be 20, right? 20 goes into both these numbers. So how many times does 20 go into 60? It's going to be 3. How many times does 20 go into 200? It's going to be 10. And then how many x plus 2's are going to cancel? Well, we have 1 on top. We have 3 on the bottom. So 1's going to cancel. We're going to have 2 left on the bottom. Okay? How many y minus 5's are going to cancel? Well, we have 1 on the bottom, so we're going to cancel out. We're going to take away 1 from the top, so we're going to have that. So now we have 10 times, let's see here, y minus 5 all over. Then we're going to have 3 times x plus 2 squared. And that's it. So basically we're doing the same thing with, like, as we do with, if you pretend this is just like x squared, it'd be the same thing, right? But it's just like kind of an expression, okay? This is a really bad 3. I'm going to fix that. Let's fix that here. Should be a 3, okay? But this is not necessary, but the answer is going to be that, okay? All right, number 4. If you'd like to try this on your own, you're going to do some factoring first, but if you'd like to try it on your own, that is totally fine. All right, let's go ahead. So for this problem, we first have to factor like I talked about, okay? And what I would do is factor each part, top left, top right, bottom right, separately, and then kind of see what happens, okay? So let's do the top left first. So let's go ahead and do that. So we have 27x to the third minus 3x. So look at what we can factor there. It does. Is there a GCF? Is there a greatest common factor? Yeah, so 3 goes into 27 and 3. And also we can pull out an x, right? So we pull out a 3x. What's going to be left inside of there? Well, 27 divided by 3 is going to be 9. X to the third divided by x is going to be x squared. Minus, and then 3x divided by 3x is going to be 1. Okay? So that's the GCF. Now, looking inside the parentheses, how many terms do we have there? We have 2. Is that a difference of squares? It actually is, right? So this is going to be squared. This is 3x squared. This is 1. So this is going to equal, here's what it's going to factor to. Let me do it over here, actually, above it. So above it, it's going to be 3x. This thing's going to factor to 3x. And then the square root of 9x squared, so we're going to do a plus and minus thing, right? So we got plus, we got minus, we got 3x plus 1 and 3x minus 1. Okay? So that's the top left. That factors to that. Kind of crazy, okay? How about the bottom left, all right? What do you think here? Is there a GCF for 3x squared minus 2x minus 1? No GCF. How many terms are there? There's 3. Is it general factoring or trial and error? I guess we skipped perfect square trinomial. It's not perfect square trinomial because there's a 3 here, right? So is it general factoring or trial and error? This is actually trial and error because there's a 3 in front, right? It's 3x squared, so we're going to do our smiley face method, okay? So we're going to do this and this, okay? We need factors of 3x squared. What multiplies to 3x squared? That's going to be 3x times x, right? What multiplies to negative 1? That's going to be negative 1 times 1. So we don't have that many options to try here, but we do need to make sure it adds to negative 2. So we're going to do 3x and x. Now where should I put the 1 and negative 1 so that it adds to negative 2x? What do you think here? If you want to pause it and see if you can figure it out, go ahead and give it a try. So where I would put it is I put plus 1 right here and minus 1 right here because 1 times x is going to be 1x. 3x times negative 1 is negative 3x, and we have negative 2x. So this is actually what's going to work. So this is the bottom left's going to factor this down here, okay? So we have this, we have this. How about the top right? A lot of factoring here. Any GCF for that one? No. How many terms are there? There's 3. Is it a perfect square trinomial? It's not. 5 doesn't work. Is it general factoring or trial and error? It is general factoring because it is 1x squared, right? So we have negative 5 on top, negative 4 on the bottom. See if you can figure out what numbers are going to multiply to -5 and add to -4. Go ahead. All right, should have been, for this one, -5 times 1. This is going to factor to x minus 5 times x plus 1. All right, now we can rewrite this. It's going to be a lot here, you'll see. Okay, we're going to rewrite this whole thing here. So the top left was 3x times 3x plus 1 times 3x minus 1 over, then we have 3x plus 1 times x minus 1. In the top right times we had x minus 5 times x plus 1, all over 3x. Okay? Now, in order to keep this a little bit cleaner here, so I usually like to multiply across, but what I would probably encourage us to do is to cancel stuff first, okay? So you can cancel vertically or diagonally to kind of clean this up before we combine it into a whole big mess. But you still can do that, but it makes it a little bit easier to do this, okay? So what's going to cancel here? Well, you can see we have 3x and 3x, so those are going to cancel. Anything else on top and bottom we can cancel? 3x plus 1 and 3x plus 1. And that's actually going to be it. So now what we have, we can multiply across now. We have parentheses 3x minus 1 times x minus 5 times x plus 1 over, then we have x minus 1. All right. Yeah, that looks like that's it. Nothing else is going to cancel, so this is our answer. As weird as it is, I would not distribute all that. I would keep it separated because that's what factoring is kind of bringing it down before it distributes, okay? All right, next ones are very similar. How do we divide fractions? Divide fractions easy as pie. Flip the second and multiply, or keep, change, flip. So it's the same process. We're going to keep, change, flip. So we have 5x squared over 4x minus 8 times, and we're going to flip it. We have x squared plus x minus 6 over x squared plus 3x. So dividing is the same thing as multiplying. You just keep, change, flip, okay? Why don't you guys go ahead and pause this, see if you can figure out what the answer is going to be. See if you can do the factoring, see if you can do the canceling, give it a try. All right, let's do this here. How can we factor? Can we factor the top left? We can't. It's just one term. How about the bottom left? That's two terms. Is there a GCF? Yeah, I can pull out a 4. So we got 4 times what? X minus 2. All right. Can we do any factoring inside the parentheses there or no? We can't. How about the top right? Is there a GCF? No. How many terms are there? 3. Is it a perfect square trinomial? No. Is it general factoring or trial and error? It's general factoring because it's 1x squared. So we're going to do this thing here. So we're going to do -6 and 1. So what multiplies to -6 and adds to 1? See if you can figure it out. It's going to be 3 and -2. So this top left is going to be, we can write it over here, I guess. It's going to be x plus 3 times x minus 2. All right, how about the bottom right? Any GCF there? There is. You can pull out an x. So we have x times x plus 3. All right, let's rewrite this now, see if it makes it easier for us. We have 5x squared over 4 times x minus 2 times, top right was this over here. We have x plus 3 times x minus 2 over, and the bottom right we have is x times x plus 3. Okay? So if you want to, you can cancel now, or you can multiply across and then cancel. I'm going to cancel now to get in the habit of show you what happens here, okay? So what's going to reduce or cancel right now? Well, we can cancel one of these x's, right? We can put this as 1x, okay? 5 and 4 we can't reduce. What can we cancel on top and bottom here? Well, we got x plus 3, x plus 3. What else do we have? X minus 2 and x minus 2. So our final answer is going to be equal to, we have 5x on top, and we have now just have 4 on the bottom. And that's our answer. Okay? All right, last one. See if you can do this whole process here. See if you want to pause the video, see if you can figure it out. Go ahead. All right, so, okay. So we got to keep, change, flip. Or dividing fractions easy as pie. Flip the second and multiply. Okay, so let's do this. So keep, change, flip. We have 2x squared minus 4x over x squared minus 144. All right, if you want to go ahead and, now that we've set it up right, if you want to try to factor it, go ahead. All right, top left, any GCF? No. How many terms? 3. It's going to be general factor. We're going to kind of move ahead here. So we have -24 on top. We have 10 on the bottom. What numbers are going to multiply to -24 and add to positive 10? See if you can figure it out. It's going to be 12 and -2. So this top left's going to factor 2. It's going to be x plus 12 times x minus 2. Okay, that's going to be this on top here. All right, how about the bottom left? Can we do anything with that? No. How about the top right? Any GCF? Yep, we can pull out a 2x. We got 2x, what's left? We got x minus what? 2? Okay. All right, how about the bottom right? We have x squared minus 144. Any GCF? No. How many terms? There's 2. What's it going to be? Well, it's a difference of squares, right? It's 2 terms. So we got x plus 12 times x minus 12. All right, let's rewrite it here. So top left was, we had x plus 12 times x minus 2 over 4x squared times, and then top left, top right, we had 2x times x minus 2 over, then we had x plus 12 times x minus 12. All right, we can multiply across, or we can do some canceling vertically or diagonally. Let's do some canceling first. What can we do with the 2 and 4? Well, 2 goes into 2 one time, 2 goes into 4 2 times. How many x's are going to cancel? Cancel 1x here. We have 1 left on the bottom. All right, we have x plus 12 is going to cancel here and here. Is that it? I think it is. Now, it's a little tricky here, but how many x minus 2's do we have on top? We have 2x minus 2, so I'm going to write x minus 2 squared to take care of this one and this one right here, okay? Over, what do we have on the bottom? Well, we have 2x times, and we have x minus 12. And that's our final answer, okay? All right, this is a very hard lesson. This is like a accumulation of like everything we've done this year, so make sure you rewatch the video if you need to. Ask questions during class. That's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.